This video is not about how the low temperatures in high altitude affect your body. This video is about how oxygen pressure falls with increases in altitude and how your body is affected by it. The column of air in the atmosphere is compressible, and because of that, its density decreases exponentially ascending from the sea level. On top of Mount Everest, the highest point on Earth, oxygen pressure is just around 53 millimeters of mercury, which is just 1/3 of its sea level values. Because of this, lack of oxygen is a major problem at the summit of Mount Everest. In response to the low pressure in oxygen at high altitudes, your body will, in the short term, increase your heart and breathing rates. These initial compensatory responses help to maintain oxygen delivery throughout the body tissues, but they are costly from an energy standpoint and cannot be sustained for extended periods. In the long term, the adaptations to high altitude include an increase in the number or the mass of red blood cells and an increase in the tiny blood vessels, capillaries, throughout the body tissues. So nowadays, with modern transportation, it is possible to fly rapidly to high altitudes, and that may precipitate mild symptoms that derive from lack of oxygen. Symptoms like drowsiness, fatigue, headache, nausea, and a gradual decline in cognition. The uncomfortable effects of low oxygen pressure are progressive with increasing altitude. These symptoms occur in most people at altitudes higher than 3,500 meters. If you happen to travel to the highest city on Earth, if you travel to El Alto in Bolivia, it is very likely you will develop these symptoms. Some people who ascend rapidly to high altitudes may develop more severe symptoms, including shortness of breath and swelling of the legs. These symptoms usually develop within the first day and last for 3 to 5 days and are caused by the low pressure in oxygen. This low oxygen pressure leads to an overreaction of the body that causes swelling of the lungs and the brain, which can be fatal if the low oxygen pressure is not rapidly reversed, first by providing supplemental oxygen to breathe and then by removing the person from the high altitude.